My name's John Mead, and I wanted to do something a little bit different. We're going to start out with a little audience interaction. I'm going to do a poll. Okay, here's a scientific poll. I'm going to ask for a raise of hands, and here's how it works. So if you think putting biochar into concrete is dumber than a bucket of hammers, you're going to be over here in the poll. You're going to raise your hand here. If you think it's the greatest thing since sliced bread, you're going to be all the way over here on the right. And then if you're right, totally neutral, you'll be in the middle, and then in between as such. So just by unofficial raise of hands, who here thinks biochar and concrete? John, that's dumber than a bucket of hammers. Any hands? Hey, all right. Skeptic, like a little better, okay. But still pretty skeptical. I think I saw 6 or 7. Neutral, just undecided, not sure, kind of in the middle of the road. Like, okay, we're not sure if this is a good idea. We want to find out more. Leaning towards favoring, thinking this is pretty cool. This is a good idea. I'd think about this for my driveway. Yeah. Okay. I'm going to get your emails after. Yep. And then, hey, this is the greatest idea since sliced bread. This is why everybody's. I'm gonna build 2 driveways, even if I only need one. Okay. So pretty good distribution. I'm gonna do this same poll at the concrete conference. We'll see how that goes. Okay, so solid carbon. My company, we're based in Oregon, outside of the Portland, Oregon area. And we provide carbon negative ingredients to make concrete a climate solution. So one of the reasons this is a bit of a big deal is that concrete has a huge carbon footprint. So concrete is the most used human-made material on the planet, and its carbon intensity comes from the manufacture of cement. Cement is what I call the fiery union of fossilized carbon. It's fossil fuels, heating kilns filled with limestone. And limestone is fossilized seashells and corals that have pulled carbon dioxide out of the ocean water to form calcium carbonate. And that carbon that's been pulled out of the ocean water is released, a chemical release of the limestone chemical reaction. And so when you combine the fossil fuel emissions with the limestone emissions, there's almost, and depending on the efficiencies, it's getting better these days, but there's nearly a pound of carbon dioxide released for every pound of cement that's created. So it's a big carbon footprint, 7 to 8% of the world's carbon dioxide emissions. So, and I'm preaching to the choir here, but our approach is, hey, let's look at photosynthesis, the oldest, lowest risk, largest scale direct air capture technology around. Photosynthesis compresses carbon dioxide out of a very dilute 420 parts per million in the atmosphere over 1,000 times. So biomass is nearly 50% carbon by dry weight. And so when we produce, we or our partners produce biochar, we're taking carbon that's destined to be released through that carbon cycle, and we're diverting that and saying, hey, let's transform that biomass, some of that carbon in that biomass, into a material that can be durably stored. And our approach is, hey, let's store that in concrete. If we're let's turn the built environment into a huge carbon sink. And so we lock biocarbon into concrete. And our vision is that you can stack technologies in the concrete industry. There's a lot of interest in the concrete world around new and innovative binders, like lower carbon cements and pozzolans. Let's take carbon out of the most carbon intensive ingredient. But if we're only becoming more efficient with our binders, that approach to lower carbon is going to have a limit. At some point, you're still going to have transportation, and you need to stack technologies. And so that's the black line that's shown here. If we want to get the concrete industry, and starting with concrete projects and moving into concrete regions, and taking the whole industry to carbon negative concrete, you really need to stack technologies. So stacking low carbon concrete binders with carbon negative ingredients is a way to start getting into some exciting possibilities, and where can we go as an entire industry. So my company, Solid Carbon, we've commercialized some products into the industry, and we've placed over 2,500 tons of concrete. Concrete's heavy, so when we say tons of concrete, it might not be as much as you might imagine, but we've done a huge variety of projects. So foundations, skate parks, driveways, insulated forms, and we've partnered with some of the biggest ready-mix partners in the Pacific Northwest near us. So Heidelberg Materials, Wilsonville Concrete Products, Knife River, Gorgecrete, and Holcim. So I'll give you some of the case studies, some of the projects that we've done over the years. We've been around for 3 years. So this is a project that we did in 2024, and in our local area there's a timber frame manufacturing facility, and they're setting up a new 20,000 square foot factory, and they sell their timber frames as, hey, this is carbon that comes out of the forest, and we can store that carbon in your building for the life of your building with our timber products. And when they found out they could have that same story in the foundation of their factory, they absolutely wanted to use our solid carbon products in their foundation. So this was a 440 cubic yard project that we partnered with Knife River to pour this project. And here's a residential project, a driveway. So this is a driveway that we did in the Portland suburbs for a customer, and this was a fun project in that we talk about low carbon binders. This was a project that we did with a cement-free concrete system. So an activated slag cement combined with rice house biochar for this residential driveway. And so poured this, we're able to get a very low carbon footprint with this particular driveway, with stacking those technologies. Burnside Skate Park. Anybody ever heard of the Burnside Skate Park by chance? So there's one skater in the group. So I didn't know this, I'm not really a skateboarder, but apparently this is one of the first do-it-yourself skate parks. And so the skating community got together and they took it upon themselves to make a concrete skate park underneath the Burnside Bridge in Portland. And it's famous, I guess it's in the Tony Hawk skating video game. You can get on that and skate through this. But they were expanding the skate park and came to us and said, hey, we want to work with your product in this expansion project. And so it was a chance for us to get into a shotcrete project with a sewage sludge biochar product that we had commercialized in 2023. This is one of our more recent projects in the Columbia River Gorge, working with a ready-mix company called Gorgecrete, and this is a passive house. And so we're finding interest from residential and commercial customers that are focused on green and sustainable construction. There is a segment of the market that is passionate about environmentally friendly construction techniques, and those are the folks that are paying a green premium for a lot of the things that they're doing in their buildings. So LEED Platinum customers, 4% of the West Coast commercial construction market goes for LEED Platinum certification. So these are folks that are paying a green premium for a lot of things in their building. And so that's a good fit for us in these early stages. While we're still smaller scale, we're able to charge an appropriate price, and it's a bit of a green premium at the moment. And we can sustain that for a segment of the market, the early adopters, the people that really appreciate that type of construction. But we know moving down the road as adoption increases and as we scale up and get to some economies of scale, that we need to get our prices down and be competitive with some other incumbent projects or products in the concrete industry. But I was at the Richmond cement plant in British Columbia, and they're producing 1 million tons of cement per year out of that one factory, and it's totally automated. There's like 6 people in a control room that looks like NASA, and they're running that. And of course, there's 6 more people coming on each shift, but it's a small number of people producing 1 million tons of product. So there's phenomenal economies of scale in the incumbent industry that we're working into. And so our pricing is going to lag. It's going to be a little bit higher price for a while before we can get into those kinds of scale. But that's the eventual vision is, concrete is huge. There's billions of tons of concrete placed every year. So getting into concrete projects is easier said than done. Even though concrete's a relatively simple recipe of cement and sand and rock and water, and then 1,000 different admixtures. Despite that relatively simple recipe, there's some real chemical and thermodynamic processes that are going on in the hydration of cement, and that's the binder reactions and the secondary supplementary cementitious process. And so we do testing, some rigorous testing and qualifications and understanding our materials and how they're going to behave in concrete systems. And there's a lot of different concrete systems and cements, but we do quite a bit of testing in-house with our research team at our own lab and at our headquarters, but we also partner with some really smart people like Lori Tunstall here at Colorado School of Mines, but Oregon State University, National Renewable Energy Laboratory, Lafarge Holcim, UC Davis. We do carbon accounting with WAP Sustainability to develop our EPDs. So currently we have 2 products that we're featuring in market right now. Both are wood-sourced biochar-based ingredients, and we purchase our biochar from producers. Oregon has a good number of wood biochar producers, and so we're able to source our products, and then we bring them to our manufacturing facility in Wilsonville, Oregon, to process them into 2 primary ingredients or materials that we're offering into the concrete world. BioLock 2.0, our 2nd generation BioLock, is an additive that replaces a little bit of the sand in the concrete mix. So we're getting carbon sequestration and good performance out of that product line. Our BioPause, we blend with some materials and enhance its reactivity, and so it's considered a pozzolon. So pozzolons are classes of materials that develop strength over time in a concrete mix, and so the primary cement reaction will develop strength in hours and days. Pozzolanic reactions take weeks and months to develop strength. So oftentimes the early strength is a little bit lower and then it comes back. And so the BioPause, we're replacing some of the cement content in the mix, so pulling out some of the most carbon intensive ingredient. And then our 3rd product that we've been developing with SBIR grant from the Department of Energy is BioAg, and that's a lightweight coarse aggregate. So this is a product that can replace the coarse aggregate in a mix for lightweight concrete applications. So more research and developments needed to get that product to market that we're hoping to do. The exciting thing about that product line is that while we're limiting to small portions of the concrete mix with our first products, with the coarse aggregate, we can put a lot of carbon into a yard of concrete. And so with that product, we can very easily imagine, even in some fairly intensive cement systems, getting to carbon neutral with that product. So what are the challenges? And somebody asked, even leading into this presentation, hey, what are the obstacles to getting into the concrete world? So I'll talk about a few of those challenges and what the strategies are to overcome those challenges. So economics. So concrete, ready-mix concrete is a commodity-based industry, and tight margins and low appetite for risk. Anybody can make concrete. I'm in the sense that there's not a lot of barriers to entry, and so there's a lot of players in the concrete industry. It's competitive and price sensitive, and so wide adoption. You need to overcome those economics. And so our thought is there's a period of time that we can develop our company and develop our products where we can charge a green premium. But 15 years from now, hopefully biochar products in concrete are so ubiquitous that we'll be producing at a scale that is competitive with other ingredients in the concrete world. A second challenge is credentialing. Products need to be credentialed, and doing that in the concrete world, most of the standards, ACI standards and ASTM standards, govern materials in concrete. They weren't written to consider carbon as an intentional component in concrete mixes. In fact, they have carbon limits in fly ash and other pozzolans, saying no more than 6%, which automatically rules us out from those standards. And so there's some performance-based standards that we can test to that aren't exactly fits, that can give us a pretty good idea and some performance-based testing results, but we're not an exact fit. So there's a new ASTM committee led by Lori that is working on a new standard to write an ASTM standard for biochar ingredients in concrete. So that's going to be a multi-year process to get a new standard written. A third challenge in the concrete world, approvals. So concrete's a bit of a team sport. Getting a new product into a concrete project, you need to get the owner, who's going to pay the bill for these ingredients on board. Often the architect needs to be on board, the structural engineer, there's a general contractor, concrete contractor, and the ready mix plant. And getting everybody on the same page can be a little bit like herding cats, but that's the challenge and the process that we enjoy. So being able to meet with each of those groups and individually and collectively, and be able to speak their language, understand their culture, their challenges and needs. Each one of those groups has a different set of needs from our products and from the concrete. So I would say a fourth challenge is carbon accounting. Product category rules that dictate the carbon accounting for concrete and concrete materials. We're set up with biogenic carbon mainly being wood products in the wood industry. There's not a lot of biogenic carbon considered in concrete, and so to do our carbon accounting for EPDs takes a little bit of extra work in that the standard categories for consideration in a concrete environmental product declaration, and this is a document that states the carbon emissions for the concrete. A1 through A3 won't allow you to consider biogenic carbon, and so we have to include stage C4 in the disposal phase in our carbon accounting to be able to consider our materials carbon negative. So if you're curious about that, I'd be happy to talk more after this with you about that. And then challenge number 5, long-term durability. Concrete goes into projects and people are hoping that they get 100 years out of their building. So how do you prove long-term durability with primarily tests that are 28, 56 days and shorter term, but even durability tests that we can do in a year. The real test is getting projects on the ground and seeing how projects age and weather. And so, it's a little bit like the Chinese proverb, when's the best time to plant a tree? It's like 20 years ago, but the next best time is today. And so we feel the same way about getting biochar ingredients into concrete projects. So yeah, our vision as a business and our hopes and aspirations for the emerging industry of players putting biochar-based ingredients into concrete is that we turn the built environment into a massive carbon sink. Questions?